You have to understand that though you might say 1s, 2s, 3s are bigger, that's all, but no, there are other things. There are areas in a in a subshell where there is no electron. So it quantum mechanics gets kind of difficult to understand. There are two effects generally, and one will outweigh the other. But what we have to learn is that this in the planetary model, the 2s and 2p are closer together. That means the distance of the second shell and all its subshells is greater than the distance of the first shell and all its subshells. If the distance is greater, then the energy of the second, all the subshells is greater than the energy of the first shell. Why is the energy greater? Because if you place two magnets far apart, they have higher energy. Similarly, if you place a positive nucleus and an electron far apart, they have high energy. So we, as we go away from the nucleus, the energy will increase. So this is there. Then what is shielding? Shielding is the repulsion. What do you mean by repulsion? Repulsion is of two types. One is the repulsion between the inner shell and the outer shell electrons. The other is the repulsion, like this is one repulsion, this is the other repulsion. So there are two kinds of repulsions taking place, two kinds of shielding. So you have the shielding of the first, these let's this be the second shell. The second shell is being shielded by the first shell electrons, and even SPDF, even the SPDF in your um they shield each other in the same shell. So what is the order? The order first is the third shell is shielded by the first and the second shell. The second shell is shielded by the first shell. What is the effect of the shielding? The effect is that there is a reduced nuclear charge attraction or effective nuclear charge. Even amongst the shells, there is an effect of shielding. So that is dependent on which is closer to the nucleus. Like if you got 4s, 4d, 4p, 4f, 4s is closest, so it will shield more. So the shielding of s is greater than the shielding of p, is greater than the shielding of d, is greater than the shielding of f. So this is amongst electrons present in different orbitals of a or subshells of a shell. Then even in exchange, even in the half filled thing, you see, what do you notice? One electron is in each d. One electron is, again, there is less shielding because they are very far apart, and of course less repulsion. So and of course, and there's larger exchange possible. That means, and this can jump here, this can jump here, this can jump here, and when it jumps around, because they are all equal for all equal positions of energy. So when they jump around, the energy is reduced because work is being done. So that's why half filled are more stable. Here also shielding comes into play because they are far apart from each other. So all these points you should know, because when you explain ionization, you have to explain distance, the shell distance, the shielding, the effective charge, the spin pair repulsion, which is kind of a shielding, and half filled, and the charge shielding within the subshells also. Now in ionic radius, like there is atomic radius, there is ionic radius. Here also, what happens is if there are more protons and less electrons, there is a greater uh, effective charge. Now, how does that come into play? You see, it's like this. This diagram I'm showing you. This diagram. If there are less electrons, like in this, there are less electrons. So they will there let's say there are about 12 protons and 10 electrons. So they will attract more. So they will because there are less electrons in the same shell, there will be less repulsion between the electrons, and they will be pulled closer. So this repulsion is important even for ionic radius. If you have an ion, you have more electrons. Supposing you have 12 protons here, let's say 17 protons and 18 electrons, then there will be more repulsion in these 18. So they will go away from the nucleus. So the size will increase. So this repulsion between Electrons of the same shell also plays a part in ionic radius. Anion radius is more and cation radius is less.